Hi, this is Skandar Rafiq and you are watching the DevCore Learn Software Development YouTube channel. Okay, in today's video we are talking about the race condition and concurrency control. So if race condition and concurrency control feels confusing to you, then this video is for you, and in the next 15 and 20 minutes we will discuss what are the race conditions and what is the concurrency control and how DBMS will use it to fix the problems, database problems. So this is very essential database concepts to maintain the data integrity and data consistency. Okay, let's deep dive into the topic. Okay, first topic is the race condition. So what is the race condition? So race condition happens when multiple transactions or user try to read or modify the same data simultaneously, and final result depends upon the timing or order of the execution. So let's discuss what by the examples. For example, one example is the Google Docs example. So concurrency control prevents the edit don't overwrite incorrectly. So if multiple users are using the Google Docs and there is no concurrency control, then one user made changes in the docs and other user will override these changes. So in this way, first user changes or get lost, and and if there is a concurrency control, so everyone sees the consistent data. So the first user and changes are not lost, and second user will see the changes, and same is the vice versa. Okay, let's see another example, classical banking account example. For example, here you can see there is two transactions being executed. One transaction user is getting the cash, and the same transaction another user is getting the cash. So transaction A, user reads the data and balance is $1,000, and at the same time user 2 in the transaction B reads the data and it is the same as the $1,000. At the same time, transaction 1 user deducts the withdrawal $200 and new balance is this $800, right? But as you see, because the user 2 in the transaction 2 reads the same $1,000 and it withdraws the $300 and write the balance is the $700. So the final result is $700, which is wrong, because the one user withdraw 200 and the second user withdrawal 300. So correct answer should be the $500. So this is the typical concurrency problem. So if there is no concurrency in any banking app, so this type of problems will be seen, right? So and the last write wins. So because the transaction B user has last write, so final balance is $700. Okay, we see another race condition, e-commerce inventory example. For example, there is one iPhone and two customer A and customer B. Both are checking the availability and got the same one available, and both try to buy the same iPhone. So user 1 deducts the one, so it balances iPhone balance is 0, and same time the user 2 deducts and try to buy, and now balance is -1. So in this case you can see due to the race condition problem, 2 iPhone is sold but the inventory has the one iPhone. So this is the also the race condition e-commerce problem. So we need to fix these problems. Okay, another example is a username registration. For example, user 1 and user 2 both try to register with the John 123, right? And check the availability, and availability is username is available. So user 1 and user 2 both try to insert the request and add the data, right? So in this case both rights are inserted, and here you can see in the database user 2 is the John 123 and user 3 also the John 123. So in this case you can see the duplicate username exists. So this is the also the race condition problems. So we need to fix these type of problems. If one user insert the request, so it should not be available to the user B. So we will see how we will fix these problems in the database. Okay, what is the concurrency control mechanism? Concurrency control is the mechanism used by the DBMS to safely manage multiple users or transactions accessing the same data at the same time. So here you can see in the all three examples, so both the users are using the same data getting the same data at the same time. So this is the problem. In this case, balance, both users reading the balance 1000. In this case, e-commerce example, both users are checking the availability of iPhone, and in this case both users checking the availability of username. So we need to fix these type of problems by using the concurrency control. So concurrency control ensures the data integrity and data consistency and correct transaction results. So we have discussed all these terms, data integrity, consistency and transaction results, in the previous video, so we don't discuss these now and move further. Okay, purpose of the concurrency control. Concurrency control prevents different types of errors. For example, first one is the lost updates. So I will discuss what is the lost update. For example, there are two transactions, lost update. Okay, this is the transaction 1 and these are the transaction 2. So transaction 1 and update the, for example, this is the one database key, ID is and balance, ID is 1 and balance is 1000, as we have seen in the first example, banking example, right? So it will write the update to, for example, $800, and this user will update the balance to $700, right? Okay, so in lost update problem, one user update is lost. For example, if T1 updated the database first and then override the T2 transaction 2 user data, so it would be 700 rather than, so in this case this data is lost. So this is the lost update. Okay. The second one is dirty reads. So let's see what is the dirty read problem. Okay, dirty read. In which the transaction 1, so we have the both transaction and transaction 2. So transaction 1 updates the data balance from initial balances as usual. If we can take the example 1000 initial balance. So it will update the balance to 800 but not committed yet. So T2 read the data and read balance to $800. But this transaction is due to some problem, it will be rolled back and write the initial balance to $1,000 in the database. But the transaction 2 uses this updated data which is the wrong. So this is the dirty read problem. So this is another problem which we need to fix by using the concurrency control. Third problem is non-repeatable reads. Okay, let's see what is the non-repeatable read problem. Okay, in non-repeatable read we have the multiple transactions same as the T1 and T2, and in the non-repeatable read problem, so each transaction has the multiple queries, for example query 1 and query 2, and it will read the data, but query 2 data is not the same as the query 1 data, not same. Because when this data is read, for example, query 1 read the balance $1,000, and in the transaction 2 it will update the data to $800, and when in the same transaction it will read query 2 read the same data, so it will read the $800. So this is problem is called the non-repeatable read. Due to the another transaction T2 updated the data. Here you can see it is updated data to 800 and it will read the updated data. So this is problem is the non-repeatable read problem, phantom read. So let's see what is the phantom read problem. So in the phantom read, transaction run the search query, and the second search query get the phantom rows, for example T1 as usual. So it will have some search query, for example get the rows which has the balance greater than 500, right? So for example in the first query 1, it will get 2 rows, but another transaction 2, it will add another row with the balance is equal to 600. So whenever in the same transaction T1 search query Q2 is executed, so it will read the 3 rows. So this is the phantom row. It will be added by the another transaction. So this problem is called the phantom rows read problem. Okay, then we have the race conditions, and race conditions we have already discussed. What are the race condition problems? Okay, now discuss how DBMS handle the concurrency problems. So there are a lot of techniques DBMS will use to handle these type of race condition problem and concurrency problem. So we will discuss all these techniques one by one. First one is the logs. So there is a shared log and the exclusive log. Shared log, this is called a read log. So because the multiple transaction can access the same data, but it is the read log. Exclusive log is the write log. So if one transaction exclusively lock the data, so another transaction cannot read the same data. It will has to wait. So we will discuss the logs in detail in the row locking section. The second one is the multi-version concurrency control. So this is the concurrency control mechanism used in the Postgres database. So a lot of other databases cannot use this type of technique. So only the Postgres databases use the multi-version concurrency control mechanism. Okay, let's discuss what is it. For example, the initial ID balance is ID1 balance is 1000, and we will need to transaction 1 update the data to $800 here. So this is the new version. It will add the new row. For example, in the same time transaction B is executed and it will read the data to, it will read the old version 1000. ID1 balance is 1000. Because this is the data is not yet committed. So when the data is committed, after this commit statement is executed, so then another transaction will read the $800. So in this way, Postgres database add the new row in the database, but it is not available to the other systems. I will explain it in the here as well. MVCC. For example, this is the ID and this is the balance. ID1 balance is $1000. So transaction 1 update the data balance to balance is equal to 800 by update statement. So instead of updating here, it will add the another row here 800. This is the new row. It will not be available to any other. For example, if T2 transaction read the balance of the ID1, so it will read the balance for the ID1 is equal to $1000. So this way it will read. This is not available to other transaction like the T2 and T3 or any other transactions. So when balance is updated and after the transaction commit statement is executed, then this row is available to any other transactions. If after the executing the commit statement, T2 is again read the data, so it will read the ID1 balance is equal to 800. So this is the mechanism is called multi-version concurrency control. It is handled by the Postgres database. A lot of other databases don't use this technique. This is very efficient technique to handle the concurrency problems and other race condition problems. Okay, row locking. So here you can see the transaction 1 update the balance to and minus to 200. For example, initial is 1000, so it is now 800 for ID1. So transaction A get the log of this row. So this is also handled in the Postgres database. This is the unique feature of the and the very powerful feature of Postgres database. So row is logged if the meantime another transaction, for example the transaction B, try to get the balance. So it will and try to update the ID1 balance. So it has to wait. It will not update this data. So this data is updated here, and the at 4 commit statement is updated, executed, and after the commit execution, lock is released. And after the lock is released, this transaction 2 is updated, and it will get the lock again and update the row. So then, for example, it is now okay, row lock. So here transaction 1, ID1 is equal to ID and balance. Yeah, this is balance is equal to $1,000, and update statement is executed same, and it will update the balance to balance minus 200. So it is now the 800. When the commit statement is executed, then and it will lock the data. This row is locked. So this is very powerful feature of the Postgres database. When T2 try to update the data by using the same statement, balance minus 300, so it will be blocked. And it has to wait. Right when the commit statement is executed, then lock is released. Then it will again get the log and then update the balance. So it will again get the balance. So balance is now 800 minus 300. So it is the 500 now. So in this way you have seen the correct balance. So this is the row lock mechanism. So we have seen the problem before in the race condition. So this problem is fixed in the Postgres by using the multiple mechanism, row locking mechanism, or multi-version control, concurrency control mechanism. So now, okay, another is the transactions. So here you can see multiple transactions are executed. For example, the transaction 1, it will update the stock and -1 the stock, update stock -1. So it will update the 100 to 99. So this immediate state data is not still persist. If another query or another transaction try to get the data, it will get 100, not 99. So when commit statement is executed and transaction is successful, so this stock 99 will be persist in the database. So after this commit statement T1, other transaction T2 will read the data again. So now it is the stock is equal to 99, and then it will process this. If due to some problem failure in the transaction 1 and T1 is rollback, so you can say stock state is again restored to 100, and other transactions like this T2 will get the stock is equal to value 100. So this is the transaction mechanism in Postgres, so to handle the race condition and concurrency problems. Okay, this is also very efficient mechanism. Another is the isolation level mechanism in the Postgres. Yeah, here transaction we have discussed, the isolation level we will discuss. Okay, first one is the read committed. In the read committed, every query in the transaction takes a new visual snapshot of the database when query starts. Okay, for example, transaction one has the two queries. So yeah, I will explain it here. For example, this is the transaction 1 and this is the transaction 2, and this has the two queries, queries 1 and queries 2. So every query, when it is executed, it will get the data, screenshot of the data. For example, here is the data and balance is ID is 1 and balance is $1,000, right? So it will get the data ID balance is equal to $1,000. If due to the same time this is modified by the transaction 2 and ID 1 is equal to $800 and it is modified and now it is $800, then the query 2 in the transaction 1 is executed, so it will get the $800 because it will get the data again from the database, so it will get the $800, and in this way it will get all the data updated by the other transactions. So this is represented in this picture. So select 1 is the value is 1000, for example, and another transaction is updated the data, so select 2 will get the new data, right? Repeatable read. Repeatable read takes a single visual snapshot of the DB when the very first query of the transaction is start. So here you can see, if I let me explain it again. Yeah, better is get the do page here. In the repeatable read, for example, the same database ID is 1 and $1,000, and T2 has the multiple queries, query 1, query 2, and query 1 read the data is equal to $100, right? And the transaction 2 update the data to ID 1 is equal to 800. So here the data is now $800. When the query 2 is executed, it will use the same visual picture. It will not get the data again. It will use the same visual ID is 1 is equal to $1,000. So in this way it will solve the concurrency problem. Here you can see, select 1, query 1 take the value 1000, and select 2 is the same value as the select 1, because it takes the value on the start of the database. When this transaction is started, it will take the value from the database, then it don't take the value from the database visual representation. So this is the repeatable read. So in this way we will solve a lot of problems. Here you can see in this table, read committed, first one, because it read again and again, so we don't have the dirty read problems. And repeatable read, same, we don't have the dirty read problem also. But in the read committed, we have the non-repeatable read problems here. So okay, in the read committed, there is a non-repeatable read problem because it will read the again and again. So if data is modified by another transaction or modified or added the row, so it will read the new rows. So this problem is there. Phantom read problem is also there in read committed because it will read again and again. So in repeatable read, because it reads the data one time on the start of the transaction, so if data is modified by another transaction, it will not affect by the first transaction, and the same is the phantom read. Right, because it will read the data only one time. This is the repeatable read. So it will read the data first time. So if data is modified by another transaction, it will not affect the first transaction. It will use the same data again. So this is called the repeatable read problem, isolation level. Another isolation and the most effective and most, but it is slower, is the serializable. So it will execute the transaction one by one. So if there is some problem in the transaction, so it will be show some error. So it will, so here you can see in this isolation level there is no problem. So all the anomalies, dirty read, non-repeatable read, and phantom read, and serialization anomaly, we don't see. So this is the most effective model in the Postgres database, but it is little bit slower. So here you can see this is prevent the dirty read committed. Each statement see only the committed data, so it is the default level, good for more steps. So the next level is repeatable read. So it will prevent the dirty read, non-repeatable read problems. Same transaction see consistent snapshot of the data. So it will be used by the reporting mechanism and analysis tools. Serializable. So it will prevent all the anomalies, dirty read, non-repeatable read, phantom read, etc. Transaction behave as is executed one by one, critical correctness, banking system, finance system. So it will use this type of isolation level. So in this way, it will fix all the concurrency and race condition problems. Okay, there are other some constraints prevent the race conditions. For example, unique constraint. For example, if we want to username or email address is unique, we need to apply this constraint at database level. So if two transactions insert the same username or email address, so first one transaction is succeeded and the second one is failed. So we will apply this unique constraint at the database level. So it is very effective constraint to prevents the duplicate data. Safe inventory. So it is the add stock is equal to 0. For example, update stock is equal to stock minus 1 when stock is equal to greater than 0. So this presents the negative. For example, if our stock is already 0, so this query will not execute. Another condition, and then we will apply the AND condition. So this will prevent negative stocks, negative stock. So this is the very useful constraint or condition we will apply to maintain the stock in a positive or at least 0, because if we don't have the stock is -1 for any product. So this is called the safe inventory. So another is the primary keys and foreign keys to prevent the duplicate data even under the concurrency. So we will need in the coming videos how to apply the primary key and foreign keys when we are deep dive into the creating the database and tables, etc. So all these techniques, unique constraints, safe inventory, primary and foreign keys, we will apply on the database levels. Important concept is rates condition are not solved only by the application code. DBMS level protections are critical because many servers processes may run simultaneously, and the distributed systems increase concurrency. So that is why here you can see we will apply these constraints at the database level. Okay, concurrency control importance is it will be used by almost all types of application, banking system apps, airline booking apps and e-commerce apps, chat applications, stock trading, inventory control. So without it, balance becomes strong, double booking occurs, as we have seen. The app can sell the many products greater than the inventory, as we have seen earlier. So app is selling the more iPhone, 2 iPhone, because but it has only one iPhone. So data corruption happens. So to fix all these problems, we need to fix all types of race conditions and concurrency control problems. So in this way, you have seen how important is the race condition to fix the race conditions and concurrency control and problems, to maintain the data integrity and data consistency and the transaction, getting the correct transaction results. So thank you so much for watching the video. In the next video we will discuss another DBMS related topic. Thank you so much for watching the video.